Hi, I am Sagar. In this video, we will discuss solution for few previous year gate questions on combinational circuits. This question asked in GATE ECE 2009 2-mark question MCQ. What are the minimum number of 2 to 1 multiplexers required to generate a 2 input AND gate and a 2 input XOR gate? So here 2 input AND gate. So if you write the equation y is equal to AB. So if we know that general equation for the 2:1 multiplexer, if S0 is the selection line, so S0 I0 S0 I1, where S0 is the selection line, I0 I1 are inputs. We can write this is the A bar B 0 into A into B. If we compare these two equations, then S0 is equal to A. So A acts as a selection line. Then I0 is equal to 0. I1 is equal to B. I0 is 0. I1 is B and selection line A. Then this Y is equal to A into B. To implement 2 input AND gate, we required only one 2 to 1 multiplexer. Next one, second one, 2 input XOR gate. We can write this for XOR gate. Y is equal to A XOR B. Means A bar B plus B bar A. For similarly, for 2:1 mux, we can write output equation. So Y is equal to S0 bar A plus S0 into B, where this A and B are inputs. So we can write instead of A, B, better I0 I1. I0 I1. If we compare these two equations, then so one variable is the selection line. Now if I assume that A is the selection line, if I assume this S0 is equal to A, then I0 is equal to B and I1 is equal to B prime. So we can write this, okay, Y is equal to A prime B plus A into B prime. Now this is the selection line. A is the selection line. For 2:1 multiplexer, this selection line is A, and one input is the B, and the second input is the B prime. But here we use only 2 to 1 multiplexer to implement this XOR gate. So we want to implement this B bar. We want to get B bar from B. So we need to implement inverter. Nothing but that we want B prime. So for this 0 into B and 1 into B prime. Like that output Y is equal to 0 into B, 1 into B prime. Here the selection line is B and B prime. This is the input I0. This is the another input I1. Now here B is the selection line. So 1 into 0. So 1 into B prime. Then output is here B prime. So now we connect like this. We will get. Now simply it acts as a inverter. This first mark acts as a inverter. So here to implement XOR gate, we required 2 2:1 multiplexer. That the output is A bar B plus A B bar. So here 1 and 2. For AND gate we required 1 mux, 2:1 mux, and for XOR we need 2 2:1 multiplexers. Option A is correct. This question asked GATE ECE 2003 1-mark question. Without any additional circuitry, an 8 is to 1 mux can be used to obtained. So if I consider general 8 is to 1 mux, I0, I1, I2, I3, I4, I5, I6, I7 as the inputs. So we need 3 selection lines for 8 is to 1 mux. I consider A, B, C as a selection lines. So we can implement any 3 variable function using this 8 is to 1 mux by considering this input either 0 or 1 from I0 to I7. Same way, if you want, for example, let us consider 4 variable function. So if you want implement this 4 variable function using 8 is to 1 mux, so here I consider 3 input variable as a selection lines. So here A, B, C as a selection lines, A, B, C as a selection lines, and one of the input variable here D as a input. So for this combination, like if we consider 0, 0, 0, for this combination the output is 0 irrespective of D. It is independent on D. So the output is 0. Similarly here 0, 1, 0. So the output is 1 irrespective of D. So same way, so 1, 0, 0 and triple 1, the output is 0, 1. If we consider like 0, 0, 0, the output is 0, 0, 1, 0, output is 1, 1, 0, 0, output is D, because that output is same as the input. So the output is D. Same way the triple 1 also, the output is same as the input D. So if we consider ABC as the selection lines, for these combinations to implement the given 4 variable function, the input for this 8 is to 1 mux are 0, 0, 1, 0, D, 0, 0, D. So we can implement this 4 variable function using 8 is to 1 mux. If you want implement another 4 variable function using 8 is to 1 mux, let us consider for this 1, 0, 0 combination. 1, 0, 0 combination, instead of 0, 1, instead of 1, 0, nothing but the output is D prime instead of D. So one of the input for this 8 is to 1 mux is D prime. For this 1, 0, 0 combination, that input is D prime. So we required D prime. So we need a NOT gate to get this D prime from D. But in the question they mentioned without any additional circuitry. So means if you want to implement this 4 variable function, we required NOT gates. So without NOT gates, we cannot implement this given 4 variable function. So the option C is correct. All functions of 3 variable and some, but not all 4 variables. This question asked in GATE ECE 2008 2-mark question MCQ. For the circuit shown in the following figure, I0 to I3 are the inputs to the 4 is to 1 multiplexer. R and PQ are the control bit, where R is the MSB. The output Z can be represented by. So the output Z can be written as, so R and S are selection, right? We can write R bar S bar I0 plus R bar S into I1, R S bar into I2, R S into I3. So where here I0 is the P plus Q prime. We can write R bar S bar I0 is the P plus Q bar, where R bar S into I1 is the P. So R bar S bar I2 is the P into Q. We can write PQ. So PQ. And that RS into I3. I3 is the P. We can write R bar S bar P plus R bar S bar Q bar. Next R bar S into P, R S bar PQ, R S P. So we can write in standard POS form. So here we have 4 variable, right sir? So 4 is to 1, the inputs are 4 variable here. So we can write R bar S bar P, Q plus Q prime. So Q plus Q prime is 1. So Q plus Q bar is 1. So we can write, so here R bar S bar Q bar plus P plus P bar. We can write like this. So R bar S P Q plus Q bar. The remaining variable is the Q here. So R S bar P Q. So here R S P Q plus Q bar. So we can write this is the R bar S bar P Q plus R bar S bar P Q prime. So R bar S bar Q bar P, R bar S bar Q bar P bar, R bar S P Q, R bar S P Q bar. So R S bar P Q plus R S P Q plus R S P Q bar. These two terms are the same, so can we neglect this term. If we simplify by using a K map, here RS PQ 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. R bar S bar PQ. So R bar S bar PQ 1 here. R bar S bar PQ prime. The PQ prime, you can write 1 here. Similarly, R bar S bar Q prime P prime. So here 1. So R bar S PQ, R bar S PQ, this one. So R bar S PQ prime, R S bar PQ, R S bar PQ, R S PQ, R S PQ, R S PQ prime. So we can simplify. This is the one quad. So we can write this is a PQ, PQ plus, and this is a one pair we can write. So here Q prime and Q prime R bar S bar, and this is the one pair we can write. So here plus S P Q prime. So if we see that option A is the correct.